All right, now let's look at this example here. Now this is giving us, again, talking about zeros, right? So it says write a polynomial f of x of degree 3 that has zeros 1/2, square root of 6, and the negative square root of 6, okay? So let's use what we know that we've learned so far. The fact that these are zeros, right, means that they solve the equation f of x equal to 0, which means that x minus each one of these numbers is a factor of f of x, right? So let's start with that, right? So that means we can write f of x right away. We can say f of x has to equal x minus 1/2 times x minus the square root of the 6 times x plus the square root of 6, right? Now, let's expand this out. So let's do these two first because these are conjugate pairs, right? So let's do x minus 1/2, and then what do we get? When we do this, we get x squared, and the middle term is going to drop out, and we get x squared minus 6. Because this is what? Difference of two squares, right? We get the difference of two squares here. So, perfect. Now we're going to distribute again, right? And what do we get? We get x cubed. Good, because we wanted degree 3, so far so good. So x cubed plus or minus 6x squared. Oh, no. X cubed minus 6x. So minus 6x and then minus 1/2 x squared and then plus 3. And so again, if I write this in decreasing order, I get x cubed minus 1/2 x squared minus 6x plus 3. And there you have it. I have a third degree polynomial, right? Where the zeros of this polynomial are 1/2, square root of 6, and negative square root of 6. Now, the one thing I do want to say is this polynomial that I created, that I used, or that I found using the information is not a unique polynomial, because I can multiply, right? So I can take f of x, I can come up with an infinite number of f of x's that satisfy these conditions. All I have to do is multiply by some a value that's not equal to 1, right? So in this case here, a is assumed to be 1, but 1 is just one possible answer. I can multiply this by any a value not equal to 0, and I get another polynomial that satisfies the conditions. Okay, so this result I got is not unique.